Welcome to our program, Astronomy for Everyone. The topic for this month's show is the Hector J. Robinson Observatory. Now, we've done other shows on this facility, but we decided to do it again because, well, this is a banner year for the observatory. We'll talk about that in a few minutes. With me here in the studio are my two guests. To my immediate left, Dr. Tim Day.
Hi.
And to his left, Tim Campbell, the president of the Ford Amateur Astronomy Club. Gentlemen, welcome you both to the show.
Thank you so much.
Thank you for having us.
Now, the observatory, it's a banner year. What makes 2014 so important for the HJRO?
Oh, it's a wonderful year. It's the 50th year that the observatory facility has physically existed. It was built in 1964 by a science teacher, Hector J. Robinson, at the middle school, and it's continuously been in existence since that time. That's really quite an accomplishment for a place like this, so we're very proud.
I think so. Now, 50 years is a long time, and I understand that some renovations were done to the observatory to bring it up to speed. Can you tell us about that, please?
Sure. A brief history. We were given the opportunity to renovate this observatory, which had fallen into disrepair, and Leo McMaster, a science teacher at the middle school, and I went ahead and set up a grant, a proposal to the Sheba America Foundation, and lo and behold, back in 1988, we actually came in and got first place and were awarded $5,000 to use as we saw fit. So we went ahead and bought all the updated equipment. The observatory was no longer in use, and the equipment was beautiful but somewhat antiquated. And therefore, using that grant money, which was awarded to us in 2008, it was a great day to present that to all the kids in the middle school, all the science students, and there's an image of myself and Leo McMaster and all those grinning students. By 2009, we had finished the work for the initial construction and had ourselves a beautiful new observatory, the likes of which are very few in this area. So we were very pleased by that. This is a nice picture of an evening star party outside the renovated observatory. There are a lot of opportunities to show also what's inside the observatory or other pictures. Here's a shot of a wide-angle camera taken through the aperture. Actually, I believe this was by Tim Campbell.
Yeah, this was, I'm on a ladder.
Leaning through the
shutter is open, yes, where it normally looks at the sky, and I'm up there on a ladder shooting down with a wide-angle lens. This was actually for a previous filming of the Astronomy For Everyone show, and I believe the scouts were there that day. So you see a lot of
some of them there in their uniforms.
So here's a great shot of the three primary instruments that we were awarded in that first grant. The biggest thing that strikes your eye is that great big telescope on the bottom with the orange celestron blazed on it. That has a 14-inch mirror at the back. It's really a magnificent telescope. It allows us to view things that are very deep in space. It looks at a small patch of sky, but it does it very, very well. The middle scope was one that we can use to look at wider pieces of sky, and the topmost scope is actually used for the sun. Now, the most important part of the telescope, or one of the most important parts, is the piece that actually moves the telescope.
The mount.
The mount.
Yeah,
there we go. There's our image of the mount. And people are always surprised to say, what is this nondescript looking piece of equipment? Well, it's actually amazingly precisely geared machinery. It's like a clockwork, and it keeps the telescope rotated in the opposite direction from the Earth's rotation so that whatever we're looking at remains perfectly still in the sky. We're always aiming to keep things as still as possible.
Now, I understand that some additional new equipment has been installed since the renovation. Can you tell our viewers about that?
Absolutely. Tim, do you want to talk a little bit about what's come in?
Well, there are two pieces of equipment that were very important. We don't have images of these. One of them was, surprisingly, you wouldn't think this would be an important piece of equipment, but mounting rings. One of our members of the Ford Astronomy Club had a set of mounting rings that actually were sized for that specific model telescope, and he didn't need them anymore, so he donated them to the school. Prior to those rings, as the telescope would move across the sky, the scope would wobble a little bit, and that would cause the images to be blurry. These are nice solid rings, and so the telescope tracks quite accurately. The other one is an auto-guiding camera that one of the high school teachers, Mr. Leo McMaster, generously donated the funding to put this auto-guide camera on there, and that allows a secondary telescope on the mount to track pinpoint stars and notice if they appear to be shifting while the telescope is tracking, indicating that the tracking is not accurate. And if that happens, it sends corrective commands to the mount so that we get sharp images now.
So it sounds like the equipment in the telescope is really brought up to essentially a professional grade observatory, pretty much?
We're continuously working to make that goal the reality. And the great news about the 50th anniversary is that thanks to the incredible kindness and generosity of many members of the FAAC organization, the school, the community in general, we've been able to add more and more sophisticated cameras. We can use computers now that are able to drive the telescope for us, and once we have everything aligned, the computer sends signals to the telescope, and then the telescope listens to those and makes minute adjustments using the guiding camera. And so we're able to take nearly professional quality images now 50 years, 5 years after the renovation, things that we weren't even able to approach early on. It's really a lot of fun.
So all of this equipment, how is it all used? What programs are there or that helps you have these programs, I should say, with this equipment?
Well, we have, as I mentioned, a very sophisticated computer, and there on the monitor is an image of a program called the Sky, which does all of this connecting to the Titan mount we saw earlier and gives it tiny, tiny adjustments to the auto-guider camera and the mount, keeps whatever we're photographing dead still, which is so important in long-term astrophotography. And in the left-hand corner of this image, you can see what looks like a smoke ring. And if you look carefully, there's a faint star in the center that exploded many, many years ago and puffed out its atmosphere to make that smoke ring. Obtaining images of this quality is thanks to having all of this upgraded material in 2014.
Now, some of that equipment can be used at night and some during the day.
Absolutely. Mm-hmm. Tim, do you want to address that?
Yeah, and I think we actually have some images here. We have the top scope that Tim mentioned has a solar telescope on it. Now we can put a filter on any of the telescopes that allow us to cut the sun's light enough to be safe so that we can look at the surface of the sun.
And that's what we're doing in this image right here. We have some.
Well, you can see the middle scope, which almost looks like a reflective mirror, and then the top scope, it looks like you see a red lens in that picture. The middle scope cuts the sun's light, and essentially you see the surface, what we call the photosphere. That's the part where you see the sunspots. The upper telescope that looks red only allows one particular wavelength of light to come through the telescope, and that allows us to see the part of the sun where you see those huge solar prominences shooting off the surface and filaments and interesting things like that. And that's in that scope as well. There is one more element that we're able to do with solar observing, and that's this little gadget here that you see in this image. This is a special solar image telescope that takes a reflection of the mirror and projects it onto a screen 88 feet away. Now you're looking at this little tripod here, but I want you to look up at that window that you see it way off in the background. That's actually a school science window, and it's shining a projection of the sun into the classroom. So students are actually seeing that image in the classroom from outside live real time.
That's amazing, and that's one of the adjunct pieces of equipment that we have there at the observatory to help with the science education. Well, you know, gentlemen, this has been an interesting discussion about the equipment and the observatory, and we're going to take a quick break, and after we come back, we're going to take a look at some of the imaging, the astrophotography that's been able to be done at the observatory with the addition of this equipment. If you have any questions, you can please send us an email. The email address you can see right down there at the bottom of your screen. And right after Term of the Month with Stephen Whitty, we'll be back with more of this discussion about the Hector J. Robinson Observatory.
The term of the month for May 2014 is Observatory. What is an observatory? An observatory really is just a place that you observe. And it doesn't have to be with any equipment. Tycho Brahe did his observing with his naked eye. He had some equipment so that he could measure the angles at which he was looking, but there were no telescopes because they hadn't been invented yet. My own observatory, my own primary observing place, is sort of my driveway or the front sidewalk in front of my house. And I bring my telescope out there and I observe. And I do that, the reason why I do that and not bring my telescope someplace else, mostly is because it's convenient. It takes a few minutes, maybe 3 minutes to set up the telescope, and then maybe 2 minutes to tear it down and, and then get it back into the house. The reason why I use my front yard is because a few years back the emerald ash borer took out both ash trees in my front yard, and so I've got quite a wide opening in my front yard. I used to observe from my backyard, which has overgrown, but it was protected. It was much better protected from nearby light sources. The light pollution in my front yard is horrendous. I call it the Mercury Vapor Observatory, and that's because, and it's not shown in the picture, there's a street light on the other side of the driveway, and that's where I do it. But the stereotypical observatory is one of these domed observatories, and here is the Stargate, which is the Warren Astronomical Society's observatory. This is on 29 Mile in Ray Township at Wilcott Mill. And the Stargate has traditionally had a 12.5-inch telescope inside. The dome moves, the dome has an opening, and the advantage of this is that the wind doesn't whistle through your hair and freeze you while you're observing. But you do need to have the observatory building be basically the same temperature as outside, so it's still relatively cold. Another popular kind of observatory is a roll-off roof. It's hard to see it in this picture, but the whole roof rolls toward you in the picture. So this sort of wooden structure in front of the building is where the roof rolls onto. And this observatory is at Dearborn Scout Camp, quite a ways north in Lapeer County. And this is an observatory that was built with funding that was by donation, and it's an outreach observatory for the Boy Scouts and for others. And then finally we have a radio observatory. This is at Peach Mountain in Dexter, that's near Ann Arbor. This was built in 1955. The radio dish, because it's not visible light, it's radio, is 85 feet across. You can see me in the foreground, but if you look real carefully, you can see somebody right by the dish. It's enormous. So observatories have different reasons for being built. They have different reasons for where they're put and so on. The term of the month for May 2014 is Observatory.
Welcome back. We're talking about the Hector J. Robinson Observatory at Lincoln Park Middle School, and with my guests, Dr. Tim Day and Tim Campbell. Now, Tim, with the continuing upgrades at the observatory, it's my understanding that this has allowed you to really move into the realm of astrophotography with a real vengeance.
It really has, and astrophotography is a real passion for some astronomers, and a good segment of the Ford Amateur Astronomy Club and many of the people who visit are interested in exactly that. It takes precise equipment and guiding. It's really becomes a hobby that just grows on you, and you get more and more sophisticated. You learn how to combine software with hardware, and you begin to generate some really exciting images, stuff that only professional observatories could have given you even 20 years ago. we are now taking here at Lincoln Park, and it's a ton of fun.
And I understand we have some examples of that.
We do. I've got some before and after examples.
Great.
The first example I'd like to show you is this one. This is obviously a galaxy. It's a spiral galaxy, and it's got a little bit of a companion off to the lower right. We got excited about this because on the left-hand side, about 3 o'clock, there's a bright star, and that's a supernova. And so this is an example of a fairly nice and exciting image, but it's one of our earlier efforts before we did much upgrading.
With the upgrades, then, you were able to improve the image quality.
Immensely, by orders of magnitude even. Tim, why don't you tell us a little bit about some of the changes and what we've been able to do?
Sure. So with we mentioned in the earlier part, we mentioned the auto guider. That was very important. We also mentioned those mounting rings that allow us to take a precise image. And we have a couple of images here that we'd like to show you. When people ask me about imaging and they see the end result, so what you're seeing now is not an end result. People sort of think that these beautiful images sort of fall out of the back of the camera, and that's not at all what you get. What we're showing here on the monitor, this is an example of what actually does come out of the back of the camera. Now if you look at that, you can see the stars are sharp, they're pinpoint, they're not blurred around, but you see this muddy, awful background. Don't adjust your TV, that really is what it looks like. It's that bad. Through an awful lot of work, we can tease this image out of it. So all of that information was in that image, but we have to take an awful lot of images to get this. This image happens to be 16 exposures. Each one was 4 minutes long to do this, and then these are all combined, and then we do an awful lot of processing.
This would be through the software process.
This would be
correct?
through the software process, and I understand you probably are going to cover this on upcoming episodes, how some of this work is done. I don't want to go into that too much. That last image that you saw was probably our favorite image that we've taken to date. You can see the rich color, the brilliant reds that stick out there. And we are just learning to process this and get these better and better. We've got to be pretty good at this. By the way, this image is called the Dumbbell Nebula. This is what happens to a star when it blows up. It's not a super big star, kind of a mediocre sized star. And this is what could happen to our sun. And one little trivia thing that I'd like to point out about this is that if that particular star were in the center of our solar system and had blown up, the outer shell that you saw of that nebula would be about 600 times farther away from the sun than Pluto, which no longer is a planet. We demoted it, but people think about how far Pluto is from the sun. So this is absolutely a massively enormous object. Pluto wouldn't even be 1 pixel away from the center of the image.
That was quite a contrast between just one shot and how with the software and additional images you were really able to bring out the beauty of that image. What do you have next?
So next we have, I think this is actually just a photograph of the moon. The moon in this particular image has a crater that we call a Copernicus crater. I called this the Copernicus crater image only because that's right at the absolute point where the dark and light side of the moon transitions.
Terminator, as we term it.
The terminator,
Yes.
exactly. But to take a picture of the moon is a very fast picture, maybe 1/100th of a second. So you don't need precise guiding to do that, and we're able to sharpen up the image. That actually was taken not through the primary telescope, that was taken through the refractor that sits on top of the primary telescope. We were able to take that image.
That was really professional quality looking image of the moon there. Now, some of the other images we have, Tim?
Well, our next image is actually one of Jupiter, and it's interesting to transition to this because to the right you see the planet Jupiter, and it's a striking object to photograph, especially once we begin to have higher and higher quality tools available to us. In this image you can see these two dark bands running across the planet, one above the equator and one below, with some people call them the equal signs. They're always there. And talking about moons, Jupiter has 4 amazing moons that were discovered by Galileo in 1609 and really did a lot to advance our understanding of the workings of the solar system.
And these 4 moons are the 4 largest of the
They're
entire
the 4 largest of the entire set, right? And they're Io, Ganymede, Callisto, and
Europa.
Europa, thank you. And we've got 2 of those planets on the previous image of Jupiter,
the
or
two-
2 of those moons, excuse
The 2
me.
moons, yep.
And one of those moons, if you look closely at that image, is actually casting a shadow from the sun on the cloud tops, and the little black shadow is in the lower right-hand corner in this picture.
At about the 4 o'clock position.
About the 4 o'clock position.
Okay.
And as you watch through the telescope, you will see not only the moons move, but the shadow cross the planet as well. And that is just one of my favorite things to observe.
Now I understand we also have some images of a non-planetary object, a comet.
We do. Comets are visitors from the outer reaches of our solar system. Sometimes they're faint fuzzies, sometimes they become nice and bright, and we can see them with the naked eye. Perhaps the most famous comet is Halley's Comet, which comes around and visits us every 76 years or so. I think the last visit was 1984, is that right?
In the mid-'80s.
Yeah, mid-'80s, yeah. So we're constantly looking for comets, and this photograph of Comet Ison is one that we were able to take, again, using the more sophisticated equipment, and the telescope allows us to take a faint fuzzy that's far out in the solar system yet, and as it approaches the sun and begins to glow and turn into a snowball, and it gets a tail, and we're able to start to see that in this image. So the head of the comet's at the bottom, and there's this beautiful tail streaming out behind it, and all the snow and dust, and this is thanks to the more advanced imaging equipment and processing we have available to us now.
This is a beautiful picture. Too bad the comet didn't live up to the beauty of the picture.
Yeah, it was a
Itself, yeah.
disappointment to the visual eye, but there we captured it.
Yes, you did. Now there's one last image that we have taken with the equipment, and if you could talk about that.
Sure. This image is, we call this the Hercules cluster. It's called the Hercules cluster because it's in the constellation Hercules. And Hercules is, this is an interesting object. Most of the things that we can see through a telescope, if it's not a galaxy, then it's probably an object that's inside our galaxy. But this object is an exception to that rule. This object is actually not inside our galaxy. It lives in a halo region above and below the galaxy. This is a couple 100,000 stars that are in this image. In nights of better seeing, you can see even more stars than this. And in fact, there are Hubble images where you see, the entire image. Your screen would go white. You would see so many stars in it. But this object is interesting because this is how astronomers know where the center of the Milky Way is. They would observe these things as they orbited the outer reaches of the galaxy and find these objects, track the centers, and pinpoint what that point is that they're going around. So we were very excited to be able to grab that image.
These have been some wonderful images, and I'm glad you were able to bring them along to show people what can be done at a facility such as the Hector J. Robinson Observatory. Dr. Tim, any final comments that you'd like to make about this facility?
Simply to make it clear to the general public that this is a facility that is free, it's open to everybody, we're open on many clear nights, and that it was entirely built with donations, grants. The community reached together and allowed us to renovate and upgrade this observatory continuously without the school system having to cough up a single dollar from their precious funds in order to make it happen. So I just want to give a big thank you and a shout out to everybody who makes this possible. It's truly a community effort.
And didn't cost the taxpayers of Lincoln Park a dime.
Not a dime.
Now, if you would like to get some information as far as contacting the observatory, we'll have the information on our scroll, and you can also see the website and some other information along the bottom of your screen. I would very much like to thank my 2 guests for being with us here in the studio to update us on developments and happenings at the Hector J. Robinson Observatory. Gentlemen, thank you both very much.
Well, thank you. It's been a pleasure being here.
Thank you for having us.
You're very welcome. And check our website for additional information as well. And coming up next is Stephen Whitty with What's Up. Stay tuned.
What's up in the night sky for May 2014? Now the days are getting longer as we approach the summer solstice in June. So the month starts out with a sunrise at 6:30, but by month's end it's more like 6 a.m. And the month starts out with a sunset at about 8:30 p.m., but by month's end it's 9 p.m. The moons start out with a first quarter on May 6th, and the moon is full on May 14th. That's when NASA can't land on the moon because it's full. On May 21st, the third quarter moon, and on May 28th, the moon is very hard to see, the new moon altogether. Great night on the new moon to see other things, other faint fuzzies and so on. On the 25th of May, Jupiter and Mercury are visible, and they're fairly close together. Jupiter is in Gemini. Mercury, I picked the 25th because Mercury reaches maximum elongation. That means that it's farthest away from the Sun, and it should be the easiest to see on the 25th. So Mercury is always close to the Sun, so very shortly after sunset, you might be able to pick out Mercury. It's visible naked eye, so it's something to check out. Jupiter is in the night sky until about midnight. Also on the 25th, here at 11 p.m., Saturn and Mars are relatively close together. So Saturn is in Libra, and it has its opposition on May 10th. So what does opposition do for us? Saturn is up all night. It's in the sky when the sun sets, and it's still in the sky when the sun rises in the morning. And it's also the closest to the Earth because at opposition, the Sun, the Earth, and Saturn are more or less in a straight line, and so it is as close as it gets to us. So it's a little bit bigger. Mars had its opposition in April, and it now sets around 3 a.m. Venus on the 25th, here at 6 a.m., happens to be very close to the moon. And the moon is in its third quarter. Actually, it's waning. Now, you don't usually need the moon to find bright Venus, but in the morning, I find it hard to get my bearings, and the moon is really hard to miss. So this might be an easy time to spot Venus. It's very bright. You can see it naked eye. It's in a small telescope, you can see a little crescent sometimes. So that's what's up in the night sky for May 2014.